In this video, I'm going to work through stage 5 of Build Your Own BitTorrent. So in this stage, we're going to parse a torrent file. We've already done decoding of B-encoded values. So now we're going to take an actual file, pull the content out, and try and get hold of the dict that's in it, and get keys from that to print out the tracker URL, which is the announce value, and the length, which is part of info length. So we're looking for two fields out of this. Let's jump into the IDE. I've copied in the dictionary format that we expect from the website, so we can start building a model for that. So rather than using JSON and SERD now, we're going to use SERD derive to set up structures that we can deserialize directly to, so that we don't have to worry about any of the serialization ourselves. So struct torrent, and we'll give that an announce field, which can just be a string. Technically it's a URL, but a string will do for now. And then give it an info field, which will be torrent info. We'll need to create that as well. And that should have length. I'll go with usize. I think these are meant to be I64s underlying this, but we'll see if it complains. It would certainly make sense if these are positive numbers. Usize again. And then pieces, I don't know what's in there. Looking at the sample torrent we've been given, it's just raw bytes. So let's assume that's just binary vec8. Cool, and then we want to make this serializable. So we need to mark it with SERD, serialize, and deserialize for both of them. So we only need deserialize for now, but it won't hurt. I'm sorry, that should be derive. Serialize and deserialize from SERD. There we go. And then we need to deal with this field here, this piece length. So it won't be able to guess that that field is going to be piece space length. So we can do a SERD rename to, and then we can copy this field name in, piece length. Okay. So that should be our models. Now we can implement the info command. So if we get an info, we should be passed the file path of the torrent to process. So we can say let file path, and then we can get it from arg2, the same way we did in the first stage. And then we want a function to load that file. So let's create a new function, load torrent file, which takes a file path t and returns an anyhow result of torrent. So it'll load a torrent if it can, error if not, and then the value of t should be anything that can be converted into a path. So just to allow this to take the widest range of things it can. Okay, then let's grab the piece of code we used before to load from string. And we can say let torrent type torrent equal to that, and this will be from bytes, and then we need to load the file to pass into that. So we can do a standard file system read and do file path.into, so that'll convert it to a path to be used with that. That will give us back our file content, and we can pass that on to this function here. Should be good, and then we want to go ahead and return that torrent. Let's just do it like that. Good, all right. Then we can use that function to implement this. Load torrent file from file path, return any errors, oops, and then we can say let torrent equals. Cool, so then we just got to print out the tracker URL and the length. Print line. Torrent.announce, and then we also want to print out the length, info length. All right. So in theory that is all. Let Let's run it and see what happens. Cool. So we're saying invalid type byte array expected a sequence. So that is probably going to be to do with this pieces. So that is the only place we've got a byte array. We won't be able to serialize that with this library then, I guess. So I think there's another library we can use, which is this surd bytes here. So we can mark this and tell surd to use a different library for that. Surd bytes. And that should then just convert directly from raw bytes into a vector of bytes, rather than trying to do anything with surd being code. Cool. Okay, so it's run the test for the next stage as well, but for this stage we are good. We have got a tracker URL and a length, and it looks like we are good. So on to the next stage.